We've all had trouble working with standard form equations. Combine them with trying to determine whether two lines are perpendicular, and it can get really tough. But today I'm going to show you how to determine whether or not a standard form equation and a slope-intercept equation are perpendicular. As you can see, we have two equations. One slope-intercept, y equals 1/3 x plus 14, and one standard form, negative 4.5x plus 1.5y equals 3. Now, it's much easier to work with an equation if it's in slope-intercept form, like y equals 1/3 x plus 14. So our first step is going to be to get the standard form equation into y equals mx plus b. So here we have the equation, negative 4.5x equals 1.5y equals 3. And as I said earlier, we need to try to get it into slope-intercept form. How we're going to do this is we're going to move negative 4.5x to the other side of the equal sign. That is going to isolate y and put it into slope-intercept form. So how we're going to go about this, we're going to add 4.5x to both sides of the equal sign, and that's going to leave us with 1.5y equals 4.5x plus 3. Our next step is isolating y even further, so it is just y on this side, not 1.5y. And so what we're going to do is we're going to divide everything by 1.5. y divided by 1.5 is y. 4.5x divided by 1.5 equals 3x. And 3 divided by 1.5 equals 2. And so that is going to leave us with y equals 3x plus 2. When we put both equations next to each other, now that they're both in slope-intercept form, we can see that the first equation slope is 3x, and the second is 1/3 x. To be perpendicular, the second equation must be the negative reciprocal slope of the first equation. And 1/3 is not the negative reciprocal of 3. The negative reciprocal of 3 is negative 1/3. So these two equations are not perpendicular. Thank you. This has been deciding if two equations of lines are perpendicular when one is in standard form.